Hi, in this video we will discuss about 2D transformations. We can define transformation as a change in appearance of an object. It may be position, size and or orientation. We have three basic transformations: translation, rotation and scaling. Let us see one after the other. Translation. Translation can be defined as a change in position of an object along a straight line path. That is, change in position of an object along a straight line path. Now, if a point P of x comma y is given, we can get the translated point P dash of x dash comma y dash by simple addition. That is, x dash is equal to x plus tx and y dash is equal to y plus ty. And we can also represent this in the matrix format by using a column matrix. X dash y dash is equal to xy plus tx ty, and that is p dash is equal to p plus t, and t is the translation vector, that is t of tx comma ty. This we call it as a translation vector. Let us see how to translate a point. So given a point p of 2 comma 3 and the translation vector 4 comma 5, it means tx is equal to 4 and ty is equal to 5. So we know already x dash is equal to x plus tx and y dash is equal to y plus ty. So what is x? X is 2 and tx is 4. So it is 2 plus 4, 6, and y dash is 3 plus 5, 8. So we will be getting x dash as 6 and y dash is equal to 8. So that point is here. So we move the point from 2 comma 3 to 6 comma 8. That is, we are going to move the point by 4 positions in x-axis and 5 positions in y-axis. So that is what we call it as moving a point along a straight line path. If it is a line, it is fine. If it is a point, it is fine. But how to translate an object like this? So if it is an object, we have to translate each and every point and we have to redraw the image with the translated point. Let us see an example. Given A of 3 comma 4, B of 2 comma 2, C of 4 comma 2, and the translation vector is 4 comma 3. So we can calculate x dash y dash, that is A dash B dash y dash, and it is 7 comma 7. So we move the point A to A dash, B to B dash and C to C dash by using the translation x dash is equal to x plus tx and y dash is equal to y plus ty, and we redraw the image once again in the translated position. So this is how an object is translated, or any transformation. We have to translate each and every point and we have to redraw the image once again. And this translation is also known as a rigid body transformation because it moves the object without deformation. So the same size and the shape is maintained in the translation even after the translation is applied. The next transformation is scaling. Scaling can be defined as a change in shape or size of an object. So given a point P of x comma y, we can just get the scale point P dash of x dash y dash by using the equation x dash is equal to x into sx and y dash is equal to y into sy, and also we call sx as x scale factor and sy as y scale factor. So this also can be represented as a matrix. X dash y dash is equal to sx 0 0 sy into xy. Okay. Now this is p dash is equal to s into p, and s we call it as the scaling matrix, a 2 cross 2 matrix. So now let us see how to apply scaling. So given a square, here whenever we want to scale a point, we have to scale an object, we have to scale each and every point and we have to move the scaled object to the scaled point. So now we are just trying to apply our equation, that is x dash is equal to x into sx and y dash is equal to y into sy. So when you just apply this, we'll be getting the scaled points like this. So we can just move the object to the scaled points. Here automatically the size is changed. So this we call it as scaling. You have to note down here s of 2 comma 2, that is sx and sy are same. Sx is equal to sy, and if sx is equal to sy, we call it as uniform scaling. We call it as uniform scaling. So let us see one more example. Here we see sx is equal to 2, whereas sy is equal to 1. In this case, if we apply the scaling, as usual, we'll be getting the points like this, and when we move the object to the scaled point, we can see only the x value is changed, not the y value. So here we are getting a rectangle. A square is converted into a rectangle. So we have seen the definition. Scaling means changing the size or shape of an object. So the shape is changed now. So here, if Sx is not equal to Sy, we call this as differential scaling. So this is a type of scaling. Let us see one more example. Here we have two set of things. So given A, B, C, D, if S of 2 comma 2, the scale factor is 2 comma 2, then we see the object is doubled in size. So this is doubled in size. We call this one as scale up. That is, if the scale factor is greater than 1, then we call it as scale up, that is zoom in, enlarging the image. So in the same case, if you consider the scale factor as 0.5, that is, it is less than 1, then the object will be there. If you apply scaling, the object will be reduced in size. So this we call it as scale down. If the scale factor is less than 1, the size is reduced. So we call it as scale down. So if the scale factor is greater than 1, we call it as scale up. If it is less than 1, we call it as scale down. If it is equal to 1, there is no change in size. There is also one more important thing we can notice here. We call it as fixed point scaling. Normally, when a scaling is applied, it is applied with respect to the origin. The points are calculated with respect to the origin. But if you want to keep a particular point unchanged, then we call it as fixed point scaling. Let us call that particular point as xf comma yf. Then the x dash is equal to xf plus x minus xf into sx, y dash is equal to yf plus y minus yf into sy. It is similar to translate the point to the origin, apply scaling, retranslate it to the fixed point. Let us see how it is working. This is our example. We have a of 2 comma 4, b of 2 comma 2, c of 4 comma 2, d of 4 comma 4. Let us assume the point B is going to be fixed. This is your fixed point. It is not going to change. So then when we want to apply scaling, first we just move the object to the origin. We apply scaling and we translate it to the original point. So see here, the point B is not changed. It is fixed. So this we call it as fixed point scaling. The last rotation, the third transformation, we call it as rotation. We can define rotation as change in orientation of an object. The point will be rotated with respect to origin always, so that we have to keep in mind. If this is your graph and this is your origin 0 comma 0, there is a point P of x comma y, which is at a distance x from the origin in x-axis, and vertically it is at a distance y. So this is, we call it as x, this is y, and this is y. So if you want to calculate if you drop a perpendicular line from that particular point, we can just find the angle between x-axis and the hypotenuse is phi. Now, we can just, by using trigonometric principle, we can get that this adjacent side is cos pi and the opposite side is sin pi. So, we can say that x is equal to cos pi and y is equal to sin pi. Imagine that we are going to rotate the point from P to P dash, we call it as P dash, by an angle theta. So, the total angle is phi plus theta. Now, if you calculate x dash is equal to cos pi plus theta. So, we know our trigonometric formula cos A plus B. If you apply that formula, cos A plus B is equal to cos A cos B minus sin A sin B. So, it is cos pi cos theta minus sin pi sin theta. We know that cos pi is equal to x. So, we replace it by x. Sin pi is equal to y. We replace it by y. We get x dash is equal to x cos theta minus y sin theta. Similarly, y dash also we can calculate. Y dash is equal to sin theta, sin pi plus theta, that is equal to x sin theta plus y cos theta. So now we got the equation of x dash and y dash. Let us try to represent it in a matrix format. So x dash y dash is equal to cos theta minus sin theta cos theta into x y. So P dash is equal to R into P. R is the rotation matrix and we call theta as the rotation angle. Here, let us see an example. We are given with a triangle with the points A, B and C. If we rotate that particular triangle by an angle theta, that is 30 degree, we may get something like this. This we call it as the angle 30 degree. So the same picture or the same image, if you rotate it by an angle minus 30, we may get it like this. This is minus 30. So we say that if the rotation angle is positive, that is anti-clockwise rotation. So if you want to rotate an object clockwise, then the value, the theta should be negative. So this is clockwise rotation and anti-clockwise rotation of an object. Let us see how to rotate a point about an arbitrary pivot position. If the arbitrary given point is xr, yr, then the transformation equation can be x dash is equal to xr plus x minus xr cos theta minus y minus yr sin theta. Similarly, y dash is equal to yr plus x minus xr sin theta plus y minus yr cos theta. So it is also similar to translating a point to the origin, rotate the point with respect to origin and retranslate it to the pivot position. Let us see how it is working. If this is your object to be rotated and you are given with 3 points, here that is shifted to the origin, rotated by an angle, say theta is equal to 30 degree, and the rotated object is retranslated to the original position. This is what we call it as pivot point rotation. So in this video we discussed about basic transformation, translation, rotation and scaling. Translation means moving an object along a straight line path. Rotation means it is rotating an object or change of orientation with respect to origin, and scaling is change in size or shape of an object, and the translation can be represented in a matrix like x dash y dash is equal to xy plus tx ty, where tx ty is the translation vector. Rotation can be represented as x dash y dash is equal to cos theta minus sin theta cos theta into xy, and where theta is the rotation angle, and scaling can be represented as x dash y dash is equal to sx0 sy into xy, where sx sy are the scaling factors. Please refer Computer Graphics by Hermann Becker for detailed explanation. Have a nice day.